So I'm going to be covering P.6, the rectangular coordinate system and graphs. So I'm just going through the material in this section. So if you watch this, you don't really need to read that section of the book because I'm covering the same stuff. Going over examples as well.
Okay.
So P.6 covers plotting points in the Cartesian plane, which I will talk about, using the distance formula to find the distance between 2 points, using the midpoint formula to find the midpoint of a line segment, and then using a coordinate plane to model and solve real-life problems. So those are the 4 things that P.6 covers. So the rectangular coordinate system is basically what we use to graph. So you have a horizontal line and a vertical line, and these are called the axes. So the horizontal is the x-axis, the vertical is called the y-axis. And then it divides it up into 4 sections, which are called quadrants. And we label the quadrants from the upper right, and we go counterclockwise. So the upper right, we have an x value and a y value. Those correspond with the axes. And in the first quadrant, they're both positive. And we write these numbers in basically in parentheses with a comma in between the 2 numbers. So this is how we talk about where things are. So quadrant 1, everything is positive. In quadrant 2, the x is negative, but the y is positive. In quadrant 3, both values are negative. And in quadrant 4, the x is positive, the y is negative. And we always refer to these in alphabetical order. So the first number is always your x number. The second number is always the y number. And then the part where these the horizontal and the vertical lines correspond. And Mike, I'm going to actually mute you because I'm hearing a lot of sound coming through.
Okay, I'll just mute my own mic.
Okay. Yeah, you can unmute it when you have a question. I was just getting a lot of feedback. So the point where the axes intersect is called the origin, and so that is referred to 0, 0. So that is basically everything is at 0, and then we refer to where we go from there, whether we're going to positive or negative numbers, up or down, and then that's how we get our signs. So this is called the rectangular coordinate system. It's also called the Cartesian plane, and the Cartesian comes from René Descartes. He was the one that sort of came up with this this method of graphing. He was, I think he lived in the 1600s, maybe earlier, but he was a mathematician, philosopher. He did a whole bunch of stuff. Basically, like, I think he was the one that said, "I think, therefore I am." So he did that, but he also did a lot of stuff with math. So we named this system after him, but most of the time it's just called the rectangular coordinate system. So those or the things that I was referring to where you have an x and a y value, those are called ordered pairs. So in parentheses, and then you'll have an x comma y. So it's ordered pair because it has a specific order to it. The x value is always first, the y value is always second. And so these are just referring to where they are in reference to our x and y axis. So you can see that we have this point in black. If this was at 1 on the x-axis and say this was at 2 on the y-axis, then the ordered pair would be 1, 2. So when you draw, you're drawing lines to the axis to kind of see what number it's at, and that's how it forms a rectangle. So that's where we get the phrase that it's a rectangular coordinate system. And so you're just counting how far away it is from 0, which is right here. So if x is 1, that's a distance of 1 away from 0. If y is 2, that's a distance of 2 away. And you don't have to count the same way as the x as you do on the y. So the distance, like in here, we have a square. It looks like they should be the same distance, but you can count differently. You can reference these in different ways. So it may look like a square, but the numbers, it's not actually a square because the distances are different. So that's sort of how we refer to things when graphing was we used ordered pairs. We put them in alphabetical order. We're kind of referencing where they are on the axes. Now, we're not going to be graphing by hand. I want you guys to be using technology. You can graph by hand on paper if you want, but you're not required to. So for graphing, I recommend using Desmos.com. So this is you just type in Desmos.com, and then there will be a big red button that says Start Graphing. So you just click that button, and then you're brought a blank graph. And so if you want to graph an ordered pair, you just type it in exactly as you would see it, where you have your parentheses, and then your x value, comma, your y value, and then that shows up on the graph. So in this case, my graph is counting the same way horizontally as it is vertically. And so this would be 1 on the x, and then we're at 2 on the y. And so when you just create a rectangle with those, that's how you get the ordered pair. So it's just a way to reference where numbers are in space. It's very similar to how we use GPS coordinates. And latitude and longitude actually use the same sort of idea. They just have different locations of what they consider 0. But whenever we're kind of referencing where something is in space, we use an ordered pair. And then when you start getting 3D, there's actually 3 points, because you have like your horizontal and your vertical, and then you're kind of like going out of the paper. Because think of this as your flat surface, basically. So anything we're graphing with just like an X and Y, it's just like a flat piece of paper that you're graphing on. And then if you wanted something 3D, you would have to add a third dimension to it. So are there any questions so far on graphing, or what ordered pairs mean, or kind of what the language here?
I don't have any questions right now.
Okay. All right. So this brings us to the distance formula. This is going to be a formula that you definitely need to use on the assignment. So this equation needs to be used for the question on the assignment that's referencing the circle, because you're going to have to find the distance between 2 points there. They're giving you the diameter, or they're giving you 2 points that are on the diameter, but they don't tell you what the actual diameter is. So you're going to have to use this formula. And this equation comes from the Pythagorean theorem. I'm not going to go through how you can get the equation. If you're curious, that's actually in the textbook. So the textbooks walks you through where this formula comes from based on the Pythagorean theorem. So you can look on that if you want. Otherwise, you just need to know what the formula is. And this is just an equation to find out the distance between 2 points, no matter where they're located. And when we're graphing, we don't really have units, so it's just a number. But if you're using this in real life, like if you were to find the distance between two things on a map, you would have units based off of what are the units are in the map, what are your coordinates are based off of. So I'm going to do a couple examples showing you how to use the formula. And I'm going to rewrite the formula so that you have that. So it's d equals, and then we have this really long square root. And then it's x2 minus x1 squared plus y2 minus y1 squared. So when we have ordered pairs, the subscript, which is the number kind of below the letter, that's just labeling it whether it's the first point or the second point. So for the ordered pairs that we have here, so if the first one is x, or is 8 comma 5, I can say that 8 is x1, 5 is y1, because it's always in alphabetical order. So the first point is always the x, the second point is always the y. And then that second point that we're given, that would be x2 and y2. So to find the distance, we're going to be replacing x1, y1, x2, y2, everything that I'm highlighting here, you're going to be replacing them with the actual numbers. And then you're going to be following the order of operations on the right side to simplify so that you can get your distance. Oops, I'm in the highlighter mode. I don't want to be in highlighter mode. Okay, so when we want to show work, we always want to work vertically. So I'm going to be working my way down, showing all of this work. So my first step is to replace these variables with their actual values. And I'm going to just do those in a different color so you can see where I'm plugging them in. So in parentheses here underneath the square root, we have x2. So x2 is 0. And then we have minus, and then we have minus x1. And x1 is 8. And then we close the parenthesis, and then we're squaring that. And then we plus, and then another parenthesis. Then we have y2, which I've labeled as 20, minus y1, which is 5. Close the parenthesis square, and then I have to make sure that I extend my square root symbol because everything is under the square root. So the square root symbol, I have to make sure I draw that line long enough so that it does cover everything that is supposed to be inside there. So when we're following the order of operations, we have parentheses first. So that means I need to simplify what's inside the parentheses before I do anything else. So I need to do let me make sure my highlighter is the right color. I need to do the 0 minus 8 and the 20 minus 5 before you square, because parentheses comes before the exponents. So I'm going to draw my square root symbol. So 0 minus 8 is negative 8. So I have a negative 8, and I need to keep that in parentheses. And then 20 minus 5 is 15. The 15 I don't have to keep in parentheses. The negative I have to because we're squaring negative 8. And without the parentheses, it says you're squaring a positive 8 with a negative in front. So just as a sidebar here, negative 8 squared is not the same as negative 8 squared. It's the parentheses. If you have the negative without parentheses, you're having a negative and then you're squaring the 8, which is 64. But when you're doing negative 8 with parentheses, that's negative 8 times negative 8, which is a positive 64. So those are two different things. So whenever you're simplifying and you get a negative, it's just a good practice to put parentheses around it, especially if there's an exponent involved, so that you're making sure that you're doing the right operation and you're typing it into your calculator right. So I simplified in parentheses. The next step is to do the exponents. So I need to square each of these. So I'm going to just highlight. And this is, if you're trying to take notes or even, if you're doing your homework, sometimes highlighting what steps you're doing really helps so that you can see the progression of what's going on. And I always recommend for people to actually write down the directions as well. So I'm not writing down the directions, I'm saying it out loud. But if you're taking notes, writing down what I'm saying, like square, do the exponents or something, that can be helpful for you. So negative 8 squared, that gives us a positive 64. And then 15 squared is 225. I'm going to just double check. I did that one in my head. Yes, 225. So now we're still simplified inside the square root. So now we need to add 64 and 225 together. And that gives us 289. So we have the square root of 289. And so I'm going to put that on my calculator. And if it comes out to a whole number, that's awesome. You can just give your answer. If it comes out to a decimal, then you're going to have to simplify the radical. In this case, the square root of 289 comes out to a whole number. And I don't have any room there, so I'm going to just write it here. So that, when you take the square root, you get 17. And so the distance between these two ordered pairs is 17 units. Because we don't actually have any specific units like inches or anything between those. So they're just units. It's just a number. So are there any questions?
I don't have any questions. I worked out the problem before you did, just to make sure I had it right.
That's a good practice. Like, I'm doing it slowly because I'm adding explanations, so it's a good practice. That helps you kind of see, oh, am I on the right track?
Good also.
Okay. So I wanted to do an example that involved negatives as well, especially because people often make mistakes once negatives are involved. Really, especially when it comes to subtracting negatives. So I'm going to, once again, rewrite our formula here. There's no reason that you have to memorize these. When you're taking this, you can refer to your notes. So you could, what I recommend doing is just making a formula sheet that you can use during the quiz so that you can always look up an equation fast without having to search through your notebook for it. So I'm going to say this is, I'm going to label my points again, x1, oops, and y1, and then x2 and y2. And then I'm going to start plugging them into the formula. So I have x minus x1, which would be 3 minus 1 squared, plus, and then y2 minus y1. So it's actually negative 2 minus 3. So we didn't have to worry about subtracting a negative, but the negatives do usually throw people off. So I need to simplify each of these parentheses first. So 3 minus 1 is 2, so that gives me 2 squared. Negative 2 minus 3 is a negative 5, so I'm going to have a negative 5. I'm making sure I'm putting that in parentheses so that I square it correctly. So that's a negative 5 squared. Then you square each number, so 2 squared is 4, 5 squared is 25. Then we add 4 plus 25, which is the square root of 29. And then you would put that in your calculator. Now, the square root of 29 gives us a decimal, so this is where we would try to simplify the radical. Now, in this case, 29 is a prime number, so we can't simplify it, so we just leave it as the square root of 9. We're not going to make a decimal approximation. We only turn things to decimals if it's basically a real-world problem, because in the real world, we don't work with fractions very much. We usually approximate with decimals. But since this is not in any context, we just leave it as it exactly is, as the square root of 29.
So if it came out to be like 5.5 or 5.75, then we would reduce to 5 3/4 or 5 1/2.
So let's say you came out to let's say we had instead the square root of 30. So what I mean by like you're trying to simplify that radical, 30 is not a prime number, but let's see, is that a good one? No, let me pick something else, something that I know. Let's do square root of 20. So the square root of 20 is the same as 4 times 5. And you can split up your square roots, so that's the square root of 4 times the square root of 5. And the square root of 4 we can do, which is 2. And then we have the square root of 5. So when I say that we would simplify the radical, we don't ever want to make it a decimal unless it's a real world problem. What we want to do is try to make that what's under the square root as simple as possible if we can. Does that answer your question?
It does.
Okay. There are other questions?
No, that was a great question.
Yeah, it was a very good question. I just randomly picked these numbers, and so I'm like, next time I teach this, I'm going to have to be more deliberate and not just pick random numbers. I'm going to try to pick one where I have to do that. So some uses for the distance formula. As I mentioned, you can use it when you're on a map if you're trying to find the distance between two things, but you can actually use it a lot with geometry. So if you're given 3 points or 3 ordered pairs and you want to know if that they make a right triangle, if you connected them, you can use the distance formula. And then I have the directions here. Basically, you'd have to find the distance between each side of that triangle. You'd have to kind of draw it on paper so you can see what points to connect, and then you would have to use them in the Pythagorean theorem to see if they work. You can use the distance formula to see if 3 points make an isosceles triangle, which is when 2 of them have equal sides. You can even check equilateral triangles, which is if there are 3 equal sides. So you're just finding the distance between each part of the triangle if you visualized it, if you drew it out. You can also use it to determine if something is a square, because squares have 4 equal sides. You can use it to determine if all of your points, if you connected them, if they make a straight line. Because sometimes, if you're just eyeballing something, it might look like a straight line, but there might be, okay, this is, I mean, it's much better if I'm not like drawing by hand, because I can't draw straight lines by hand. Let me see if I can draw this better. So this might look straight, but maybe there's a slight, it's not exactly straight, you know, it goes off to the side, and so you think they're all on one line, but maybe the third point is slightly off, and it's slightly angled, and you can't visually tell. So you can use the distance formula to determine that. Basically, if you have 3 points, the 2 shortest distances add up to the longest. If they add up to the largest distance, then they're all in the same line. If they don't, then they're not collinear, which just means they're all on the same line. So that's good if you're, you know, for visual inspections. If you're trying to make sure everything is straight and you're not sure if it is or not, you can use the distance formula. But so in algebra, I usually use the distance formula just for practice for like geometry applications, but in real life, it's used a lot, especially with airplanes. So when you're flying and you're trying to find the distance, you can use the distance formula, because when you're flying, you don't have to worry about taking turns or anything like that. You can do it like a straight shot. It is a little more complicated with airplanes because actually the Earth curves, so it's not exactly straight. So the formula is slightly different, but it's the same idea. They're basically using the distance formula to determine the distance between the 2 points that you're flying. So the next thing that's in this section is the midpoint formula. And so the midpoint is basically you're just taking 2 points, so 2 ordered pairs, and you're averaging them together. So when you're averaging, you add up your values, divide by how many there are. So since we have 2 points, we're dividing them by 2. So you're just adding the x values, divide by 2, adding the y values, divide by 2. So it's a really easy formula. So I'm going to rewrite formula here. We have x1 plus x2 over 2, and then y1 plus y2 over 2. Now notice that there's no equal sign here. Because we're finding an ordered pair, we don't really have an equation. So when you're using the midpoint, you want to keep the notation the same. So you want to make sure you keep those parentheses, because those parentheses are telling us that we have an ordered pair. I see a lot of people forgetting those parentheses, or they're not really using the notation right. And math is one of those things where if you don't use the right notation, you're actually communicating something differently. It's the same thing with that negative, whether you have parentheses around the -8 or you don't. Those parentheses mean something. So it's really important to emulate all of the notation. Don't just say, oh, I don't need that. Assume you need it. Write down everything, because you may not realize how important something is. So I'm going to label my points here. I'm going to call the first one, we have x1 and y1. And then the second point, we have x2 and y2. So I'm going to do the same thing I did with the first example, where I'm going to color code and highlight just for the first walkthrough. So I have my parenthesis, and then I plug in my numbers. So x1 is 1. Then I have my plus. And then x2 is 8. And then I'm dividing by 2. And then my comma, that's very important. Then I have y1, which is 4, plus and then y2, which is also 4. And then I'm dividing that by 2, and then I have my parentheses. So it's really important to make sure you're writing everything here, and you want to make sure you're writing your fractions this way. I see a lot of people, especially when they're typing, for example, maybe writing 1 plus 8 divided by 2. That's not correct, because that actually is saying that you're only dividing the 8 by 2. So that's why I don't use that slash. I always write it vertically, so that's a straight bar for the fraction, because otherwise you're not actually communicating what you think you are communicating. So don't try to take shortcuts. Don't try to conserve space by smushing your fractions onto a single line of lined paper, because that makes you more prone to writing things incorrectly from what you intend. So following the order of operations, we need to simplify these fractions, and that means we need to add the numerator. So I'm going to add both of these together, which is simple enough. So that gives me 9 over 2 and 8 over 2. And then you want to reduce if possible. So 9 over 2 does not reduce, so we would leave it as a fraction there. But 8 over 2, that can be reduced to 4, because 8 divided by 2 is 4. So our midpoint is going to be 9 over 2 and 4. And so you're going to leave it as a fraction. You don't want to turn it into a decimal. You don't want to make it a mixed number. When we work with algebra, and once you go into higher level math, everything needs to be in improper fractions because they're easier to deal with. So don't do extra work by making it a decimal or a mixed number. Just leave it as is.
That was going to be my question. Thank you.
Yes. A lot of people want to, like, I will convert it to a decimal if I have to graph it by hand, because that will allow me to graph it, because, you know, it's a lot easier to graph looking at the decimal. But since you guys can graph everything in the calculator and online, there's no reason to do that. And unless it's a real world problem where you may actually need the decimal version, just leave it like that. It's actually less work. You're not as prone to make a mistake with rounding or making a mistake or you're trying to make it a mixed number. So don't do more work than you need to, even if you think it makes things look nicer. Are there other questions? Okay. All right, so here's the second one. Again, we're going to find the midpoint. And I actually, because I would encourage you guys to work along with me as I go through this. The best way to learn is to kind of do it at the same time. And then that way you can check to see where your mistakes are. So I'm going to start by writing the midpoint formula. And I always rewrite my formulas. It helps me remember them, because I find writing things down helps me remember. So I don't ever try to learn math by just watching. I have to write it down. And I use color coding because that helps me remember things as well, because I'm a very visual person. So I can remember in my notes, oh, this was blue or this was some other color. So I'm going to label my ordered pairs. So I have my x1, my y1, x2, y2. And I recommend that you always label those until you can start doing these in your head. You know, I've been teaching math for so long, I don't label them anymore. But when you're first starting out working with ordered pairs, it's very easy to use the wrong numbers and accidentally add your x and your y together instead of your two x's. So that's why when you're starting out, definitely label these so you can double check you're using the same numbers. It's a good way to check your work, because then you can make sure you've plugged in the correct numbers, because you can go back to what you had labeled. So for the midpoint, we add our x values. So that's going to be 2 plus -5, and then that whole thing is divided by 2. And then we add our y values, 10 plus 4 divided by 2. And then we need to simplify the numerators. 2 plus -5 is a -3, so that gives us -3 over 2. And then 10 plus 4 is 14, so we get 14 over 2. And then -3 over 2 does not reduce, so we're going to leave that as a fraction. and 14 divided by 2 is 7. So again, I made up these numbers, and I just happen to once again come up with something where the second value is a whole number. Now I'm actually going to bring up Desmos so that you guys can see this. You can see the midpoint on there. So I'm going to just pull this over. So this is Desmos when you go to the online graphing calculator and you just click Start Graphing. And then this is what you see, and you just type in your ordered pairs. So I'm going to just kind of, I wanted to make it small so that I can, there we go, okay, because I want to be able to see the actual values here so I can type them in. So we have 2, 10, so I just literally type in what I see, and then I can hit enter. And then the second one is -5, 4, and I hit enter. Okay, so now I'm going to adjust my window so you can actually see there. So you can click and drag this graph part so you can actually see your 2 points. So those are 2 points, and then you can see whether your midpoint actually looks like the midpoint. So I'm going again put in what we just found the midpoint for. So I have my parenthesis, I type in a -3, and then the slash next to the shift button, the forward slash allows you to get a fraction. So I do the forward slash, and that gives me -3/2, and then comma, and then 7. And then you can see, and I can even apply a label, that is the midpoint. So you can see visually it does look like it's halfway between the 2 points that we started with. And so that's a good way to just kind of see, oh, that midpoint formula does actually give us the midpoint. You know, you can see where that's located. Are there any questions on that?
No, I'm good.
All right. So going back to the presentation. So the midpoint formula is used a lot more in real life than in algebra. So you can use it if you need to approximate something that's halfway between what you know. So let's say you are plotting the sales of something. Let's say you have how many sales, like sales of cars. So maybe you know how many cars were sold in 2000, and you know how many cars were sold in 2010, but you don't know how many were sold in between there. And you want to kind of estimate based off of those 2 points how many were sold in 2005. So since 2005 is halfway between 2000 and 2010, you can use the midpoint formula to come up with an estimate for that. Your x value would be the years. Time is always going to be your x value. Time is always the input. And then whatever the number of cars you sold, that would be the y value. So you can create ordered pairs and then use the midpoint formula to find out an estimate. It's not going to be the exact value because real life isn't always a straight line, but it can give you an estimate. You can also do this if you're gathering data, and let's say you're gathering data every 10 seconds. A lot of people that take classes here usually work in some sort of manufacturing, or a lot of people have very hands-on jobs where you're gathering data. So if you're gathering data every 10 seconds or maybe every 10 minutes or something, and you're trying to estimate, okay, I have this data, I'm missing some data in between. So maybe you have 10 seconds, but you want to know what it would look like if you're doing it every 5 seconds. You can use the midpoint to kind of estimate what would have happened if you had measured every 5 seconds. And it's just an estimate. It's not exactly, because real life never follows math as we want it to, but it gives you kind of a base point to start with. And then again, if we go back to maps and anything with GPS, you can use the midpoint formula to find the halfway point, which is good for traveling, especially like for the holidays. My family is in various different places, so we try to meet up halfway. So we just, if you got the GPS coordinates or the longitude and latitude for your 2 locations, you can use those as your X and Y, find the halfway point, and then figure out where on the map that is and see if, okay, is that a good place to meet up? Of course, it's not always perfect in real life. because usually the roads are not perfectly straight. So time-wise or distance-wise, it may not actually end up exactly in the middle, but it's a good way to kind of have an idea of where to meet up if you want to go halfway. So that's P.6 in a nutshell. So that's basically everything that section covers. So now you don't really need to read that section. You've basically gotten everything that you need from those. So that saves you some time reading and taking notes because you've got everything you need here. Do you guys have any questions?
No, that was
Question
awesome.
about.
Thanks.
I don't have a question about this chapter. I have a question about another part of a different chapter. Chapter
Sure.
2.
Sure.
What is a linear equation? Like, what does it look like? That's all I needed to know.
So a linear equation is mx plus b. So you have a y and an x, and it's usually y equals mx plus b. So your x is your input, your y is the output. It's called linear because there's no exponent on it, and when you graph it, it forms a line. The value m here is what we call the slope. That determines how much we change. So it tells you if your slope is 2, you're going up 2 every time you increase x by 1. This value for b is what we call the y-intercept. And so that's the point that it hits on the y-axis. So if I bring back Desmos, I'm going to just x these out. So I'm going to just make up an equation like y equals 2x plus 3. So, or I've typed in plus 4, so we'll do 2x plus 4. So that y-intercept, that is where it hits on the y-axis, and I can hover over it, and so on this vertical, which is the y, our x value is 0, because we haven't gone left or right anywhere, but our y value is 4. The slope is 2, which means you go up 2 and over 1. So if you add 2 to the y, you get to 6, and you're adding 1 to the x, you're now at 1 instead of 0. So that's what the linear equation is, and so if there's a negative in front, that actually makes it go down instead. And then this is, the down 2 over 1 works if you're counting by the same scale, but let's say the y-axis was stepping by 2 instead of 1. So if it's stepping by 2 instead of 1, when you're going down 2, you're going down 1 tick mark because each tick mark is worth 2 now. And then you would be going over 1, or actually because it changed the tick mark so they're counting by 1/2 instead. That's actually not what I wanted. So it actually doubled how many tick marks in. So if you're going down 2 units from 4, you're actually in this case going down 4 tick marks. And then you're going to the right one to go down 1, 2. So you're going, it's counting how many units you're moving. So a negative means you're going down 2 units and then to the right one. If it's a positive 2, you're going up 2 units and then to the right one. It's not tick marks that we're counting. It's how many units in regards to the actual numbers. So that's a linear equation. This stuff is from section 2.1. So when you're going to do the discussion, you're going to want to make sure you read through 2.1 and then watch my videos on 2.1 before you do the discussion, because that will help you. Oops, that is a really bad writing of 2.1.
Does your YouTube channel cover that, or is that just on our website, on the Blackboard site?
It will be in both. So if you go to the course coordinator resources on the left navigation bar, and then there's going to be, I think I made the link green, it'll say course coordinator videos. You click there, and then you go to week 2, and then it'll have a list of videos. And all of those videos that are listed there are also on my YouTube channel.
Thank you very much.
You're welcome. Anything else?
I think I can figure out the rest just watching your YouTube videos and reading the chapter and stuff. I hope. If I have any
I
questions,
hope so too.
if I have any questions, I definitely will call by Monday or Tuesday for sure.
Okay.
Thank you very much for your time. You're a very good teacher. Thank you.
Oh, thank you. I'm glad that this was helpful.
Thanks. Have a good day.
You too.
Bye.
Courtney, do you have any questions? Says your mic is on, but I don't hear anything.
Can you hear me now?
Yes.
Thank you so much. I thoroughly needed this. It was a great review and everything.
Good.
Thank you.
All right. You're welcome.
Have a good weekend.
You too. And I'll make sure I'll be sending out the recording and like an email and everything about like next week's session once I plan it. So
Awesome.
watch for that. All right. Bye.
Bye.